Welcome to Nardar Academy. In this video, we are going to discuss about parallel forces. A system of forces which are acting on a rigid body such that their lines of action do not meet at a point are called parallel forces. Okay, the parallel forces are classified into two types. One is like parallel and another one is unlike parallel. Like parallel means all the forces are acting in the same direction like this. See, these are the lines of action of these forces. They do not intersect at any point and they are in the same direction. So these set of forces are called like parallel forces. And look at these two forces. So these two forces have parallel lines of action but they are in opposite direction. So these are called unlike parallel forces. Okay. Now we are going to find the resultant of two like parallel forces which are acting on a rigid body. Let us assume two like parallel forces P and Q are acting on a rigid body at points A and B. P is acting at A, okay, and Q is acting at B. Then the resultant of these two like parallel forces is given by P plus Q. That is, the magnitude of the resultant is P plus Q. And where does this resultant act? It will be acting along the line of action of, see, this is A and B, no, these are the points where the forces P and Q are acting. You join this AB by means of a straight line, then the resultant of P and Q will be acting somewhere along this AB. Okay, so it will be at a point C where the C divides the line AB in the ratio P into AC equal to Q into CB. Okay, so when you have two like parallel forces P and Q, then their magnitude of the resultant is P plus Q, and this resultant will be acting at a point C where P into AC equal to Q into CB. Okay, next one is resultant of two unlike and unequal parallel forces acting on rigid body. Okay, unlike means what? They are acting in opposite direction. So let us assume P is acting in the upward direction like this and Q is acting at B along the downward direction. Now join this AB by means of a straight line. Okay, now here I am assuming that this force Q is greater than force P. Then the resultant of these two unlike unequal parallel forces will be Q minus P. Okay, whichever force is greater, that one minus the least force. So Q minus P will be the resultant of these two unlike unequal parallel forces, and this resultant will be acting at a point C where C is lying on the line AB. Okay, and the C divides the line in the ratio like P into AC equal to Q into CB. The C will be more closer to the greater force. Okay, whichever force is greater, the C will be closer to that one. Okay, why do we take unlike and unequal? Suppose if the forces are equal, unlike and equal forces, then the resultant will be 0. Okay, right. So for the most general case, we have taken unlike and unequal parallel forces. Next one is condition for equilibrium of three coplanar forces acting on a rigid body. So let me take two forces P and Q in the as like parallel forces. Okay, then the resultant of these two forces is given by P plus Q, which will be acting at some point C, right? So this is my resultant. So if I have one more force and if I want to achieve equilibrium, the third force must be equal and opposite to that of the resultant of this P plus Q. Okay, in that case only I can achieve equilibrium, because if I have all the forces are in the same direction, all the three forces are in the same direction, then equilibrium cannot be achieved. Okay, so in order to achieve equilibrium for three coplanar parallel forces, at least one of the forces must be in the opposite direction and it must be equal and opposite to the resultant of the other two forces. Okay, using this concept, I have derived the result that P by CB equal to Q by AC equal to R by AB. These are nothing but CB, AC and AB are nothing but the distance between the lines of action of the forces. Okay, so what do we conclude here? If we want to achieve equilibrium in case of three coplanar parallel forces, each force must be proportional to the distance between the other two. Okay, so this is an important condition for doing problems. So whenever you want to achieve equilibrium for three parallel coplanar forces, then each force must be what? Proportional to the distance between the other two forces. Okay, right. Next one is center of parallel forces. See, suppose we have a system of parallel forces acting on a rigid body. Okay, either they may be like parallel or unlike parallel. If we have a system of parallel forces, then they all the parallel forces together will give you a resultant. No, that resultant will be passing through some point. No, that point is called center of parallel forces. The direction will also be parallel to the given forces, and the point of action of the resultant is called what? Center of parallel forces. Okay, let's see some problems based on these definitions. First problem, two men, one stronger than the other, have to remove a block of stone weighing 300 kgs. Okay, so two people are there, they have to uh, remove a stone, and the weight of the stone is what? 300 kg. So how do they move that weight? By means of a light pole. Light pole means the weight of the pole is negligible. Okay, so we have to consider only the weight of the stone. So the weight of the pole is negligible, that is why they have given it as a light pole. So in this problem only the weight is what? 300 kg, that only we have to consider. No need to consider the weight of this pole. Whose length is 6 meters? The length of the pole is what? 6 meters. The weaker man cannot carry more than 100 kgs. So two people are there, no? One person is weaker than the other. This weaker man, how much maximum he can lift? 100 kg. But total weight is what? 300 kg. So where must the stone be tied to the pole so as just to allow him his full share of weight? So the question is, see, let me show you the diagram. So this is the diagram. This is a pole. AB is the pole. So in the pole they are going to attach the stone. Okay, so suppose, let me assume that they are going to attach it at the point C. Okay, if A is the weaker man and B is the stronger man, this person A cannot carry more than 100 kgs of weight. This is what they have given there, no? Right? So where should this C be positioned such that they can lift the weight? This is the question. What is the thing they have given here? Given the question is, where must the stone be tied to the pole so as just to allow him his full share of weight? What is the full share of the weaker man's weight? 100 kg. So at the maximum load, how can he support 100 kgs? So let me assume this person A is sharing 100 kg. So what must be the other person's load? 200 kg. So weight I have separated. So I want to find where this C should lie. That is, where should I position? That is, where should I place the stone? Let this be C, which is at a distance of x meters from the person A. What is the total length of the pole? 6 meters. So if this is of length x, this remaining length will be what? 6 minus x. Okay, so these are like parallel forces, no? Because weight always is a downward force, so these are like parallel forces. So the resultant of like parallel forces is what? P plus q. So P plus q is what? 100 plus 200 is equal to 300. So that will come here, that will be coming here at C. So what is the condition for this C? P into AC equal to Q into CB. So what is P? 100 and Q is 200. So 100 into x. AC's length is x and CB's length is 6 minus x. So 100 into x equal to 200 into 6 minus x. So simplify this result. So 300x equal to 1200 or x equal to 4 meters. That means the stone should be tied at a distance of 4 meters away from this man, the weaker man. Okay, so here this distance will be what? 2 meter. So it will be very closer to the stronger man. Then only they can lift the stone. Okay. Next problem. Two like parallel forces P and Q act on a rigid body at A and B respectively. So I have two like parallel forces P and Q, which are acting at A and B. Now, so the resultant will be somewhere at C. P plus Q is the resultant. It will be acting at C, where P into AC equal to Q into CB. So this is the result for the first statement. What is the second statement given? If Q is changed to P square by Q, what they are doing? P is remaining the same as it is. Instead of Q, they are changing it to P square by Q. Look at the second diagram. Here, this is q, no, initially it was q, now it is changed as p square by q. So show that the line of action of the resultant is the same. So let us come to it later. We want to find the resultant in this case. See, this is force p and this is force p square by q. So their resultant will be what? P plus p square by q. It will be acting at some point. Already I have taken c here. So let me take c dash. So this resultant will be acting at some point c dash such that p into AC dash is equal to P square by Q into C dash B. Okay, right? So throughout you multiply by Q. So PQ AC dash equal to P square C dash B. Next throughout you divide by P. So Q into AC dash equal to P into CB dash. See, look at this result. So here what is this telling? That is for this corresponding statement, the diagram I have drawn here. Q into AC dash means A, B, C dash is here. So here Q into AC dash equal to P into C dash B. Okay, that means actually I have started with this diagram. With this case, I ended up with this result. That means what? This and this are equal. That means if you replace the force Q by P square by Q, the resultant is simply obtained by interchanging the forces. Okay, so C dash is the point where the resultant Q at A and P at B acts. So comparing this, what do we conclude? The resultant is the same as it would be if the forces were simply interchanged. Okay, that's all. Then next one. Next problem. Three like parallel forces acting at vertices of a triangle have magnitude proportional to opposite sides. So I have three like parallel forces acting at the vertices of a triangle. So let me draw a triangle ABC. At A, force P is there, at B, force Q is there, and at C, force R is acting. Three are like parallel forces. Okay, right. So all are like parallel forces only they have given. What are the magnitudes of the forces? Each is proportional to the opposite sides. So here this is P, no? What is the opposite side? BC. Already I told you, okay, whenever you are taking a triangle ABC like this, if this is the vertex A, the opposite side is of length small a. This is vertex B, then opposite side's length is small b. And similarly, this is vertex C, opposite side length is small c. So here what they have given, each force is proportional to the opposite side's length. That means P is proportional to A, Q is proportional to B, and R is proportional to C. That is the magnitudes. Okay. So these are given things. What we have to prove, show that the resultant passes through the incenter of the triangle. We have to prove the resultant of these three forces passes through the incenter. Okay, so whenever problems of this type is given, first you take any two forces. Okay, let me take these two forces Q and R. Q is acting at B and R is acting at C, no? So apply our resultant of like parallel forces here. So what will you have? The resultant of Q and R will be acting at some point along this line BC, isn't it? So let me take that point as D. Okay, this is the point. Let me assume this is the point where my resultant of Q and R acts. Then how will you write the resultant? Q into BD equal to R into DC, isn't it? So bring this DC to this side. So BD by DC equal to R by Q. Okay, but R is proportional to C and Q is proportional to B. That is magnitudes, no? So replace R by Q by C by B. Okay, from this result I am replacing here. So, but C by, what I am getting, BD by DC equal to C by B. But what is C? C is length of AB, right? Okay, so instead of the C I am writing AB. And similarly B. B is nothing but length of AC. So by AC, BD by DC equal to AB by AC. Now you see, BD by DC equal to what we are getting, AB by AC. This implies, this is the result when you have AD as the internal bisector of angle A. Okay, that is internal. When this AD is the internal bisector of angle A, then only you will get this result. That is BD by DC equal to AB by AC. These are standard results that you have to remember in mechanics for doing problems. Okay, so this is the property of internal bisector of angle A. So I have combined two forces and I have found the point where the resultant of these two forces acts. But with this one I have to combine this P also, no? Okay, now let me consider this diagram. So now I have only these two forces. One is force P at A, vertex A. Another one is force Q plus R at D. then the resultant of these two forces will be lying along the line joining the point A and D. Okay, randomly let me assume it as the point I. Okay, let I be the point where the resultant of these two forces lie. These two are again like parallel forces, no? So how will you write the resultant? Q plus R into Di equal to P into Ia. Okay, then rewrite the expression di by Ia equal to P by Q plus R. Again, P is equal to A and Q plus R is nothing but B plus C. Okay, right? So what we have, AI, just I am reversing this, AI by ID equal to B plus C by A. Okay, that is AI by ID equal to what we have written, B plus C by A. This result implies that this is the incenter. I is the incenter of triangle ABC. This is the property of incenter. Okay, so what do we conclude? The resultant of the three like parallel forces passes through the incenter of the triangle. Okay, right. Then next problem. This is also similar to the previous one. Three like parallel forces PQR act at the corners of a triangle ABC. Prove that their center is the centroid of the triangle if P equal to Q equal to R. Okay, so similar to the previous problem. In the previous problem, what they have given, each force is proportional to the opposite side's length. Here, they have given all the three forces are equal. Okay, what we have to prove? The resultant passes through the centroid. What do you mean by centroid? Centroid is the line of intersection of medians, isn't it? Okay, now as usual in the previous problem, let us take the two forces Q and R acting at B and C. So, the line of action of the resultant of this Q and R will be somewhere in between B and C. Let me take that point as D, so that what I have, Q into BD equal to R into DC. So BD by DC equal to R by Q. But they have given in the question all the three forces are equal. So by cancelling, what do I have? BD by DC equal to 1. That is BD and DC are in the ratio 1:1. That means what? D is the midpoint of BC. Okay, right? So D is the midpoint of BC. Now I'm left with only these two forces. One is force P at A, another one is force Q plus R at D. So the resultant of these two forces will be lying at some point joining the line AD. Let me assume randomly it has the point G somewhere here. Okay, right. Now apply the resultant of like parallel forces. P into GA equal to Q plus R into DG. So AG by GD is equal to Q plus R by P. But again, what do we have? All the three forces are equal, no? So I can replace Q plus R by 2P by P. So what do I get? AG by GD equal to 2:1. What is this AG by GD? 2:1 means what? That is nothing but centroid, isn't it? Because only centroid only divides the line in the ratio 2:1. So what do we conclude? The resultant of all the three forces passes through the centroid of the triangle when the three forces are equal in magnitude. Okay, then last problem. A light rod is acted on by three parallel forces P, Q and R acting at 3 points at distance 2, 8 and 6 feet respectively from one end. So I have a light rod. Let AB be the rod. Okay, three forces are acting. First force is acting at 2 feet distance from some fixed point. So from A, let me assume C at 2 feet distance, and here I have a force P. Second force is Q and it is acting at a distance of 8 feet. So let me assume here the second force Q is there and it is acting at 8 feet distance. Let me take this point as E. It is acting at 8 feet of distance and let this be Q. Another force is 6 feet. Okay, 6 feet which is acting, which is my third force R, which is acting at where? Which is acting at 6 feet distance. So this is 6 feet distance. Okay, right. Now, what is the distance between the forces? So the distance between the forces is CD. CD is equal to what? 6 minus 2, 4, and DE equal to what? DE equal to 2 feet, and because 8 minus 6 no, and CE equal to what? 6, because 8 minus 2 equal to 6. What is the condition of equilibrium for three forces, coplanar parallel forces acting at a point? Each force is proportional to each force is proportional to the distance between the other two forces. So P is proportional to distance between RQ, Q is proportional to distance between RP, and R is proportional to distance between PQ. It is enough only if you write this alone. Okay, right. So P by 2 equal to Q by 4 equal to R by 6. So cancel 2 throughout. So what do we get? P by 1 equal to Q by 2 equal to R by 3. That means P is to Q is to R is equal to 1 is to 2 is to 3. Okay, right? So the forces are in the ratio 1 is to 2 is to 3. Okay, this is what I have represented in the diagram. See, if I take this P and Q as like parallel forces, the magnitudes of P and Q are unknown. Okay, so if P and Q are taken like this, then your R must be equal and opposite to that of the two forces. Okay, so the R must be in the upward direction, and magnitude of R should be what? Equal to P plus Q. So P plus Q will be acting downwards, but R will be acting upwards. Okay, that is what I have represented in the diagram. Okay, for doing problem, what should you remember? This one, that is each force is proportional to the distance between the other two forces. Okay, that's all. Thank you.